When you start working with fiber optic connections, you'll start to see that there are many different kinds of connectors at the ends of these fiber. One type is an ST connector. This stands for straight tip. You can see the straight tip of the connection coming right out of the end of the connector. You'll also notice that the connection itself has these little bayonet type connections on the end. So you normally push it into the link and you turn it just a bit to lock it in place. That way you can be rearranging cables and moving fibers around, but those are in there pretty tight. The only way to get them out is to turn them and then remove them. That way you can be assured that it's not going to accidentally pop out of the fiber connection. One important characteristic when working with fiber is that the light only goes in a single direction, so you're usually connecting a pair of fiber at the same time. And when you see the different fiber pairs, you'll notice that they sometimes will have different colors so that you can differentiate between one end of the fiber and the other. Because on one end, you're usually plugging a connection into the transmit. On the other side, you're plugging in that same connection into the receive. They have to be swapped on the other side. So it's very easy to keep track of that if you happen to know what colors you have on both sides, and you can synchronize those together. Usually, you're not going to get an access light or status light on the device you're plugging into, and if you happen to get it wrong, you can simply reverse those connections. Another type of fiber connector is the SC connector. This may stand for subscriber connector or standard connector, or the way I like to say it is a square connector, because although the fiber inside is round, the actual connector around it is a square. These are usually combined in pairs. You can see an example of this here, and there is a key on one side of it, so it can only fit into those links in a particular way. In this connection, you'll see that the pairs have even a connector between them so that you can keep them all going the same direction. You can see in this one that black is on the right and red is on the left. On the other end of the fiber, it's reversed because you need the transmit going to the receive, and so the red is on the right and the black is on the left. That certainly saves you a lot of time when you're plugging these in. There's a lot of fiber and a lot of cable in the room. You can have those connectors on there to keep straight which side goes into which connection. Another fiber connector type is the LC connector. This may stand for lucent connector, local connector, or little connector, because this is a little bit smaller than the other connectors that we've looked at so far. These are usually combined into a pair. You can't really separate these out, which makes it very easy to work with in very large environments. Some of them even have the ability to put markings right on the fiber so that you can tag those and know what they are, especially if you have them running across long distances. The fiber connectors in this actually still have the caps on the end of them. So to install them, you would simply remove those caps, and you'll notice there's a locking mechanism as part of the connection itself. You slide it into the device, and it will lock in place when you push it all the way through. That way, it's not going to come out of that connection very easily. You have to push down on that connection to release the lock, and then they'll slide out of the equipment. If you work at all with telephone connections, then you certainly run into an Rj11 connection. This is a 6-position, 2-conductor standard connection. The Rj11 that I'm showing here shows those 6 positions, and you can see inside of this there are 2 pieces of copper in there that are receiving those. And when we receive a telephone line, they usually have 2 connections inside of them. Whenever you see one that has 4 connections, here's a cable that has wired all 4 of those wires, but you'll notice it's only going to be connecting to 2 connections inside. That's usually done so that you can use the other outside pair as additional signals going through that. Usually when you see that, it is an Rj14 where there are 6 positions and 4 conductors that you're using, very often used when you have 2 phone lines that you need to pass through the same cable. These are almost always used for telephones, and they are smaller connection. And as we're about to see, the Rj45 connection that may be on your system for Ethernet is a little bit larger, so you have to be careful not to plug in your Rj11 cable into that larger Rj45 connector. You can see this Rj45 connector a little bit larger, and that's why we have to be careful about making sure that we're plugging in an Rj45 cable into it. This is an 8-position, 8-conductor cable with an 8-position, 8-conductor connection that you might be plugging into. This is almost always used for a network connection. Most generically, Ethernet is what we'll see this, but occasionally WAN connections and other type of connectors on your network that are inside the infrastructure might also use these same types of form factors. So you have to be careful that you're plugging in an Ethernet cable into an Ethernet connection, and those are almost always going to be Rj45. When you're working with wiring, there is a lot of cable and a lot of fiber that you might find in the infrastructure, so you have to be very careful about how you're planning out all of this wiring that you're working on. It's very common once you install wiring for the first time to make sure you test the wire so that you can be assured when somebody plugs in their equipment that it's going to work properly. It's very common to make mistakes when you're punching down cables. You might also even find brand new cables that you receive that aren't mapped properly to the ends of the cable. You might have pin 1 not going to pin 1. And for a straight through cable, that's a pretty important consideration. So you might want to make sure that you have something like a wire mapper that you can plug into both sides of the cable to make absolutely sure that the cable is mapped properly on both sides. Your cabling and your fiber is the foundation of your network. You want to be absolutely sure that you're able to send traffic at very high speeds across the network. So your cable has to be installed properly, it has to be maintained properly, and because of that, many organizations get a person dedicated to cabling, somebody who knows how to do the cabling, they are understanding the process for punching down, and they can do the testing you need to make sure that the cabling is working as efficiently as possible. Obviously, if we all decided how to do cabling ourselves and everybody had a different way of doing it, then we'd have a lot of problems when we tried to interconnect all of our devices. That's why there are a number of standards associated with cabling. We're going to look at one from EIA-TIA called the 568A and the 568B. And this is for 8-conductor 100 ohm balanced twisted pair cabling. This is what we're using when we're plugging in our network connections. An important thing to consider is that the 568A and the 568B use a completely different wire map on the connector. So generally, an organization is going to decide which standard they plan on using, and they use that for everything. They'll decide we're going to use 568B for everything, and generally, that is the most common that you'll see, is most organizations decide to use T568B, and they use that entire wire mapping throughout their infrastructure. The important thing to remember is you can't have one side on T568A and the other side on T568B. That's not going to work. They have to match on both sides of that. As long as you have those matching on both sides, you can interoperate in your organization. Some links might be 568A and other links might be 568B. That just becomes more difficult to troubleshoot later on when you have to go back to those connections, which is why everybody tends to standardize on a single type. If you look at these wire mappings between the 568A and the 568B, you'll see there are some similarities. For instance, the cable that you would plugging in numbers 4 and 5 and 7 and 8, those pins are exactly the same on A and B. Notice that it's blue and white and blue on 4 and 5 and white and brown on 7 and 8. The things that are different between those two is that you have the green pair on 1 and 2 and the orange pair on 3 and 6 on the A. And on the B side, it's exactly the opposite. So when you're looking at a cable, you can look at those colors and you should be able to determine instantly what type of standard this particular cable is using. A connector type we commonly see on video connections, you may also see this on legacy coax Ethernet connections, is a Bnc connector. This stands for Paul Neal, Carl Councilman. So this is Bayonet Neal Councilman. That's where we got the BNC from. From this connector, we're able to plug in and use cables like coaxial cables and Ethernet. We used RJ11 for 10-base-2 connections. You may also run into this when you're plugging in higher-end video connections and sending some of the high definition across those connections because you're plugging it in and you're locking it in place by turning it. So it becomes very difficult to pull those out. You have to push it back in and turn it the other direction to finally remove the BNC from that connector. And because of that, we're able to use these connections and feel very good that they're not going to accidentally fall out of those connections. Another common coax connection type that you probably have in your home is an F connector. This is commonly used in television cable, something like the RG6/U that's coming into our homes. And it connects onto the back of our televisions, onto the back of our cable modems with this connection that is threaded. So we would spin it onto this connector and it's on there very tight. It's very, very difficult for that to come out. And because of that, it's a very, very solid connection. And that's why when we are spending time putting cable across neighborhoods, we want to be sure they're not going to accidentally pull out, which is a very common reason that the cable companies have used this connection type. It's very difficult to remove this unless you sit there and untwist it from that connector to finally remove it from those connections.